Welcome to Simplifying Rational Expressions Part 2. In this video, we're going to focus on how we handle simplifying these rational expressions when we have a negative leading coefficient. We always want our x squareds in front to be positive as often as we can. So what we're going to do here is we are going to see how we handle this tiny little negative, which doesn't seem like it should cause any problems, but unfortunately it will. So, very first thing, take a look at what we have here. I have a negative coefficient up top. I don't have it on the bottom, so I'm not going to do this step to the bottom. On the top, I'm going to factor out a negative 1 from everything. Okay, so I'm going to have a negative 1 on the outside of my parentheses. And what I'm going to do is change the signs of both terms. It was a negative x squared, now it's a positive x squared. It was a positive 2x, now it's a minus 2x. So we factored out that negative 1 first, then we kept the denominator the same, x squared minus x minus 2. And now we can pretty much do the same things that we did in the first video. It's just that we really wanted to make sure we took that negative 1 out. Otherwise, it was going to cause some problems, and well, we don't want to deal with problems if we don't have to. So, we have simplified it partially, but there's more to be done. So, let me erase my little title here, and let us continue on with simplifying this rational expression. All right. Whoops. There we go. Let's move this up over the top a little bit. Okay, now, let's look at the top. The top is not a trinomial like the bottom, so I'm not going to use the diamond method. What I do notice, though, is that both terms have an x. So I can factor out the smallest number of x's both of them have. This is x squared, so this has 2 x's. This is x to the first, so it's 1x. I can take 1x out of both pieces. So if I take 1x out, it's going to chill on the outside with the negative 1, and it's going to become a negative x times x minus 2. There is my factored top. I have factored out a negative x so far, and it's now become x minus 2. For the bottom, we're going to do the diamond method just like we did in the previous examples. So a is 1, b is negative 1, c is negative 2. 1 times negative 2 is negative 2. B is negative 1. What's going to multiply to negative 2 but add to a negative 1? Why, negative 2 times a positive 1, of course. And since a is 1, we don't have to do the division step. So my factors are x minus 2 and x plus 1. Notice that we have x minus 2 on top and on bottom, so those will cancel out. And in the end, we're going to have negative x on top, that's the only thing left, over x plus 1. Don't forget, we need to say what values of x will make this expression undefined, and that can come from the sides of our diamond method. Take the opposite of the sides. So our answer is negative x over x plus 1, comma, x cannot equal positive 2 or negative 1. Those numbers will break the function and make it undefined. So there's an example of how we handle these when we have negatives. Let's try one other and see what we can do. Here we have 10 minus 2x all over x minus 5. And let's pretend that we didn't watch that first example and we decide that we don't need to factor out a negative 1, or we don't even know that a negative 1 could be a possibility. What can I factor out of the top as it is right now? I've got a 10 and I've got a 2x. What can I factor out of both of those to factor the top? And hopefully you say a 2. 2 would be correct. So if I factor a 2 out of the top, I get 5 minus x. And looking at the bottom, the only thing I could factor out of the bottom is a 1, which won't change anything. So the bottom is still x minus 5. All right, well, they both don't have a 2, so I can't cancel out the 2. And this is a 5 minus x, and this is an x minus 5. They look very similar. It's because they are. They are very, very similar. The only thing that's different is here the 5 is positive, here the 5 is negative. Here the x is positive, here the x is negative. It's almost like they're opposites. So, doesn't matter, top or bottom, we want to make those the same, and we can do that by factoring out a negative 1. So, I'm going to take a negative 1 out of the top, just because I would prefer to make the top match the denominator. So if I take a negative 1 out, that's 2 times negative 1 times negative 5 plus x. And negative 5 plus x is the exact same thing as x minus 5. Why is it the same thing? Here the 5 is negative, here the 5 is negative just through subtraction. Here the x is positive, here the x is positive. So they are the same thing, and we get a negative 2 on the outside. The original denominator is still there, but now that we made them the same, they cancel. So our final answer here is just that it's negative 2. 10 minus 2x over x minus 5 is really just negative 2, no matter what value you put in for x. Your simplified fraction in the end is going to be negative 2. But don't forget, x cannot equal what number? Right, x can't be 5. Because if x is 5, it will break the function, or the rational expression, sorry. And there we go. That's it for this video. We've got simplifying rational expressions without negatives, and now we've got them with negatives. Hope this helps, and good luck.